or factor label method is the way we're going to do a large variety of problems, converting from one unit to another. We can do density like this. We can do multi-step problems. And this is probably one of the biggest advantages this method has over other methods to do conversions. So what we need to start with is we need a conversion factor, which is a ratio of equal measurements. So, $1 equals 100 cents. And that's why we can turn that into those fractions. And since the numerator and the denominator are actually equal to each other, we can multiply by it and it doesn't change the value. Now there are metric prefixes like kilo, centi, and milli, and others that give us equalities. So for example, 1 kilometer is 1,000 meters. 1 meter is 100 centimeters. 1 meter is 1,000. Whoa, too many zeros. Is 1,000 millimeters. And you can substitute any unit for the meter, and the relationship is the same. For equalities between metric and the customary US units like inches and whatnot, there's a chart in your book. So let's do an example here. So the first thing you need to do is read the problem and figure out what you are given. So 15 kilograms. You also need to figure out what you want and put that unit that you want over on the right. Now you need to multiply this by a ratio. And the ratio needs the unit that you were given on the bottom and the unit that you are looking for on the top. Now we know that relationship, so we can fill in the numbers. Kilograms on the top and bottom cancel, so we can multiply and get our answer. So another example, how many kilograms are 150 pounds? So, I'll use my colors again. 150 pounds is what we were given. Kilograms is what we are looking for. So we need our ratio, our conversion factor. The kilograms are going to be on the top, and pounds on the bottom. And I happen to know offhand that 1 kilogram is 2.2 pounds. We can look this up. To more sig figs if we needed it to have more significant figures. But since I'm going to erase my decimal here. So that I only have 2 significant digits. Then I don't need to look that up, because I'm just doing this as an example. So we have this time 150 divided by 2.2, and so that gives us 68 kilograms. Now, we could have a problem that is going to be a multi-step. So we do the same thing. We identify what's given. So we're given 1 day. And what we want is seconds. So we're going to follow the same procedure we did before and give ourselves a fraction. Day goes in the bottom, so it cancels. Seconds goes in the top. But wait, we don't know a relationship between days and seconds, so we can't do that. So we need to take days to hours. Now we're going to need another fraction. And so we're going to bring hours to the bottom so that it cancels. So we're going to use seconds and hours. But wait, we don't know that relationship either, so we can't put seconds there. But we do know hours to minutes. So, running out of room here. We want seconds for our answer. So if we put seconds on top of that last fraction, we can put minutes in the bottom because now we know these relationships. So in 1 day we have 24 hours, in 1 hour we have 60 minutes, in 1 minute we have 60 seconds. So we do the math and we have 24 times 60 times 60, which gives us 86400 seconds. Okay, so let's do another example. We'll do this top one. So we have 472 ounces. So ounces are going to have to go on the bottom. We're looking for kilograms. So kilograms would go on the top. But when we look on our sheet, we don't have ounces to kilograms. We do, however, have ounces to pounds. So then we can bring pounds to the bottom and kilograms to the top. So we look up those relationships and we see that in 1 pound there are 16 ounces, and in 1 kilogram we have 2.2046 pounds. I'll go ahead and use the more precise number for this example. So 472 divided by 16 divided by 2.2046 gives us 13.4. Now this relationship is exact, so it is this that limits our sig figs.